Hello everyone, welcome back. This video is about projectile motion. So what is projectile motion? So in the previous videos we learned that linear motion is motion in a straight line. But non-linear motion is motion that is not in a straight line. So therefore projectile motion is non-linear motion. We have here motion along a parabolic path. So what are the techniques you need to know before we answer projectile motion questions? The first one is we need to treat vertical and horizontal components separately. We also need to know that horizontal distance equals horizontal speed times the time of flight. Horizontal speed remains constant in a flight. And at the highest point, the vertical speed is 0, and acceleration due to gravity and on Earth is always taken as 9.8 meters per second squared downwards. So here we have type 1, which is horizontal projection. The initial velocity is in the x direction. So this is v naught x, and v naught y is equal to 0. So the initial vertical velocity is 0. And we said that the horizontal component of velocity does not change. So v naught x is equal to vx1 is equal to vx2 equals to vx3 and so on. So now we understand that v naught x is equal to Vx at any point, and Vx is equal to x over t. So we need to use this formula for horizontal motion because we said Ax is 0. The horizontal component of acceleration is 0 throughout the projectile motion. It does not change. And because Ax is 0, therefore x or y equals v naught times t. So in this case, we are dealing with horizontal motion, and therefore we put x instead of y. So x equals vx times the t times the time. And the range, we have here the range. You can put xx or x. The range is the maximum horizontal distance traveled by an object. Okay. And as we said, if the vertical motion is downwards, we can just take all quantities to be positive when we sub in the values. And then we can say downwards at the end. Alright, so AY is 9.8 meters per second squared downwards. AX is equal to 0. V naught x is equal to Vx at any point. And also we said V naught y is equal to 0. So I will just summarize it here. So we said V naught y is equal to 0. Ax is equal to 0. So Ax is the horizontal component of acceleration, which is 0. And also AY, we can take it as 9.8 meters per second squared downwards. Alright, so let's look at this question, okay, and let's see what do they want us to find. A golf ball is launched horizontally from a height of 5 meters with an initial horizontal velocity of 10 meters per second. Calculate the range, which is the horizontal distance traveled of the golf ball. Okay, so what is the range? So we need to find this maximum distance that is traveled by the object, which is from the base of this, we can call this a cliff, to where the object lands. So what is the range? So the range, as we can see, is a maximum horizontal distance. It's a horizontal distance. So therefore we need to use this formula to find x. So let's make x the subject. So x, the range, is equal to Vx or V naught x times the time. So do we know the initial velocity in the x direction? Yes, we do. The initial horizontal velocity is 10 meters per second. So I know V naught x is equal to 10 meters per second. So I know V naught x, which is Vx, so Vx times t is the same as V naught x times the time. So I know the value of V naught x, the initial horizontal velocity, but do we know the time taken? We don't know the time taken. Okay, so we need to find the time. So we need to look at the other formulas. So maybe let's look at the vertical motion formulas. So, and we said in vertical motion, we have constant acceleration. Ay is 9.8 meters per second squared downwards. Okay, so because we have constant acceleration, we can use these three equations to find the unknowns. And now we are interested to find the value of t, the time. So which formula do we use to find t? So because I know the height of the cliff, let's call this a cliff. Okay, so I know the value of y. You can call this xy or y. So let's leave it as y for now. So y is equal to 5 meters. So this is the value of y. So I know the value of y. I know V naught y is 0. Even though V naught y is not given, we need to know that in horizontal projection, the initial vertical velocity is 0. So V naught y is 0. 0 times the time is 0. And then half times ay. I know the value of ay, 9.8. And yes, we can use the third equation to find the value of t. So let's write the formula first. So y is equal to V naught y times t. We said that is equal to 0. So V naught y times t plus half times ay times t squared. Okay, so now we said V naught y is 0. So 0 times the time is 0. And now we can just sub in the values. Y is equal to 5. And then you have half times 9.8. So here, because the vertical motion is downwards from the beginning to the end, we can take all quantities to be positive. Times t squared. So 5 is equal to half times 9.8 is equal to 4.9 t squared. And now t squared equals 5 over 4.9, and t is equal to the square root of 5 over 4.9. So here we don't need to put plus minus because time cannot be negative. And therefore the value of t is equal to, so the square root of 5 over 4.9 is equal to 1.01 seconds. So it took 1.01 seconds to reach the ground level. Alright, so now we are ready to find the value of the range. So let's do it here. So we said x is equal to V naught x times t. V naught x is equal to 10 meters per second, and the time is 1.01. And 10 times 1.01 is equal to 10.1. And let's look at the units. Here the height is in meters and the velocity is in meters per second, so the range should be in meters. Okay, so the range is 10.1 meters. So this value, the maximum horizontal distance, is equal to 10.1 meters. Alright, so let's look at question 2. A ball is launched horizontally from the top of a cliff with an initial horizontal velocity of 7 meters per second. So here I know the initial horizontal velocity, so v naught x is equal to 7 meters per second. It takes 5 seconds to reach the ground level. So it took 5 seconds to reach the ground level. Okay. Question A, calculate the height of the cliff. So here we need to know what is the value of y. What is y? So I will just call this y, the height of a cliff. And let's find the value of y. But what do we know? We know the initial velocity in the vertical direction is equal to 0. So we know v naught y is equal to 0. Even though this value is not given, we have to know that v naught y equals to 0. So what is the height of the cliff? So let's use the formulas from the vertical motion. So if we look at this formula, the third formula again, y is equal to v naught y times t plus half times ay times t squared. I think we can use this formula because I know v naught y is 0. I know the time to reach the ground is 5 seconds. And I also know the value of ay, which is 9.8 meters per second squared downwards. So let's use this formula to find the value of y. So this equals to v naught y times t. So we have here 0 plus half times ay, which is 9.8 times t squared. And in this case, what is the time? The time is 5 seconds. So times 5 squared. So now let's use the calculator and calculate. So 5 squared is 25 times a half times 9.8. This is equal to 122.5 meters. So this is the value of y. So we now know that y equals 122.5 meters. Okay, let's look at the next question. The next question is, what is the range of the golf ball? And we know the range is the maximum horizontal distance traveled by the object. So this is our range. So how do we calculate the range? Because now we are looking at horizontal distance, so we have to use the formula from the horizontal motion. And we said for horizontal motion we have constant velocity, ax is 0. So therefore we can use v naught x, which equals to vx at any point, which equals to x over the time. Okay, because the acceleration is 0 in the horizontal direction, therefore velocity equals x over t. Okay, so here I know v naught x, I know the value of the time taken to reach the ground, okay, from the beginning to the end. Therefore I can use this formula to find the range. So let's make the range the subject. So x equals v naught x times the time. v naught x is equal to 7 and the time is 5 seconds. And 7 times 5 equals 35 meters. So here x is equal to 35 meters. Question C. Calculate the velocity of the ball at t equals 3 seconds. So we know it took 5 seconds to reach the ground. So what is the velocity of the ball at 3 seconds? So what is the value of this velocity? V. And to find the value of V, we need to find the x component of this velocity, which is Vx, and then find the y component of this velocity, which is Vy. And as we can see here, Vx is to the right and Vy is downwards. So what is Vx? Remember we said the velocity in the x direction is the same, is equal, and since we know v naught x is equal to 7 meters per second, therefore Vx at 3 seconds also equals to 7 meters per second. So now we know at 3 seconds Vx is equal to 7 meters per second, and we know the direction. In this case, the direction of Vx is to the right. And now we need to calculate Vy. What is Vy? So let's use one of the three equations from the vertical motion. So maybe we can use the first equation. Vy equals V naught y plus Ay times the time. Because in this case, I know V naught y is equal to 0. So V naught y, as we can see here, is equal to 0 plus Ay is 9.8 and the time is 3. So calculate this. We get maybe 29.8. So let's use the calculator. 9.8 times 3, so it's 29.4 meters per second downwards. So Vy is 29.4 meters per second downwards, and Vx is 7 meters per second to the right. And now we can quickly draw a vector diagram. Vx is 7 meters per second to the right, and Vy is 29.4 meters per second downwards. And as we can see, we connect the two components from head to tail, and the resultant is from the start to the end. So this is our resultant velocity, which is v. And as we can see, we need to find the angle so we can state the direction of the velocity. So what is v? In this case, we have a right angle triangle, so we can use Pythagoras theorem to find the value of v at 3 seconds. So v equals the square root of 7 squared plus 29.4 squared. And let's use the calculator to determine the value of the square root of 7 squared plus 29.4 squared. We get 30.2 to 18464 meters per second. I will just round it to one decimal place, which is 30.2 meters per second. We also need to state the direction. So theta equals, in this case I will use tan ratio. So tan inverse opposite over adjacent. So Vy is opposite to theta, so opposite is 29.4 and adjacent is 7. So tan inverse, let's use the calculator, of 29.4 over 7 equals to 76.6 degrees. And now we can say the final answer is V equals 30.2 meters per second, and the angle is 76.6 degrees to the horizontal. So directed at 76.6 degrees to the horizontal. Alright, so I will just say here 76.6 degrees to the horizontal. Or we can also say east 76.6 degrees south. So using the major points, we can also say east 76.6 degrees south. So the angle starts from east, so east 76.6 degrees south. For compass bearing, you would need to tell me the angle from south to the resultant. So 90 minus 76.6, which is 13.4 degrees. So using the compass bearing, we can say south 13.4 degrees east. Okay, so this is your resultant and this is the the angle. So south, angle, east. So these are correct answers. Question D. Calculate the resultant velocity just before the ball strikes the ground. So just before the ball hits the ground, what is the final velocity of the ball? So the steps are the same as question C. So we need to find Vx and then find Vy, and then we can find the resultant final velocity at 5 seconds. So just before it hits the ground, the value of t would be 5 seconds because it took 5 seconds to reach the ground. So just before it hits the ground, the value of the time would be 5 seconds. Okay, so what is Vx? We said Vx equals V naught x, which equals to 7 meters per second. We also need to find the value of Vy, and I will also use the first formula to find Vy. So Vy equals V naught y plus Ay times the time. So what is Vy? V naught y is equal to 0 plus Ay is 9.8, and the value of t would be 5 seconds. And 9.8 times 5 equals 49 meters per second. The direction of Vy would be downwards, and the direction of Vx is to the right. And now we can draw a vector diagram to find the resultant final velocity. So Vx is 7 meters per second to the right. And Vy is 49 meters per second downwards. And the final velocity, the resultant final velocity would be from the start to the end. This is the resultant velocity. I will just call it V. So let's use Pythagoras theorem to find V. And then once we find the value of V, then we need to find the value of theta. So V equals the square root of 7 squared plus 49 squared. This equals to, so 7 squared plus 49 squared is equal to 49.497. So I will just round it to one decimal place. So 49.5 meters per second. And theta equals, so we know tan theta equals opposite over adjacent. So theta equals tan inverse of opposite over adjacent. So theta equals tan inverse. Opposite of theta is 49, adjacent is 7. And using the calculator, we get 81.86989.765. So I will just round it to one decimal place, and the final answer would be 81.9 degrees. And this angle is directed to the horizontal, so from the velocity to the positive x-axis. So we can also say east 81.9 degrees south. So the angle is between east and south. So, and because the angle starts from east, so we would say east 81.9 degrees south. So the final answer for this question is 49.5 degrees is the value of the velocity, and the direction is at east 81.9 degrees south. Using compass bearing, you would need to find this angle, which is 90 minus theta. So 90 minus 81.9 degrees, we get 8.1 degrees, and we can say south 8.1 degrees east. So this answer is also correct. So this answer is using compass bearing. The last part of question 2. Calculate the displacement of the ball at t equals 3 seconds. So at 3 seconds, what is the displacement? So what is displacement? The displacement will be from start to the end. So if this is 3 seconds, this would be your displacement S. So what is S? And to find S, we need to find the value of Sx, the x component of S, and then find the y component of S, which is Sy. And once we know Sx and Sy, then we can use Pythagoras theorem to determine the value of S. Alright, so what is Sx? Here I will use the equation from the horizontal motion where the velocity is constant. We said v naught x is equal to Vx, which equals to x over t. But in this case, instead of x, I will put Sx. So what is Sx? So now let's make Sx the subject. So Sx equals v naught x times the time. V naught x is equal to 7 meters per second and the time is 3 seconds. Alright, so 7 times 3 is equal to 21 meters. So now I know Sx equals 21 meters. Now let's find the value of Sy. So for Sy, I will use y equals v naught yt plus half a yt squared to find y or Sy. So Sy is equal to v naught y times t plus half times ay times t squared. So instead of y, I am putting now Sy. Alright, so let's sub in the values. We know v naught y is 0. So here we have only half times ay times t squared. So half times ay, which is 9.8, times t, which is 3 squared. And now using the calculator, 3 squared, which is 9, times a half times 9.8 is equal to 44.1 meters. So Sy equals 44.1 meters downwards, as we can see here. So Sx is to the right and Sy is downwards. Alright, and now we draw the vector diagram. Sx is 21 meters to the right, so this is Sx, and Sy is acting downwards. The line is supposed to be longer because 44 meters is greater than 21 meters. Alright, so but this diagram is not to scale. So Sy equals 44.1 meters. And now we can use Pythagoras to find the value of S, the displacement. And then once we know the value of S, then we will calculate the direction of the displacement. So first, let's find the magnitude of the displacement, the value of the displacement. So S equals the square root of 21 squared plus 44.1 squared. And now let's use the calculator. We get 48.84475,407. I will round this answer to one decimal place. So 48.8 meters. So the value of S is 48.8 meters. So now we know S, 48.8 meters. And now we can determine the direction of S. So let's find theta. Theta equals tan inverse. Opposite of theta is 44.1 and the adjacent side is 21. So let's use the calculator and determine the value of theta. So tan inverse 44.1 over 21, we get 64.5 degrees. And now we can use the major points to finalize our answer for the direction. So this theta is between south and east, or east and south, because the angle starts from east, so you would need to write east first, the angle is 64.5 degrees south. So here, let's highlight the final answer. The value of S is 48.8 meters, and the direction is east 64.5 degrees south. Alright, so now let's look at type 2. In type 2, we have projection at an angle that is greater than 0 degrees and less than 90 degrees to the horizontal. So in this case, this is our initial velocity, v. Our angle, as we can see, this angle is greater than 0 degrees and less than 90 degrees to the horizontal. So the path followed is also a parabola. The horizontal motion is a constant velocity motion. So v naught x equals to vx. So I will write it here. V naught x is equal to vx, which equals to x or xx over the time. And the vertical motion is an accelerated motion under the influence of gravity. So ay will be 9.8 meters per second squared downwards, and ax is equal to 0. So ax equals 0 and ay equals 9.8 meters per second squared downwards. So what is the difference? The difference is that the initial vertical velocity v naught y is not 0 anymore, so that the object moves up and across at first and then moves down and across. So in horizontal projection, we said v naught y is equal to 0, but in type 2, v naught y does not equal to 0. I will write it here. V naught y does not equal to 0. And we have to remember one more thing. At maximum height, Vy equals to 0. So Vy equals to 0 at maximum height. Alright, so let's look at this question and let's see how we go. Question 3. A ball is kicked from the ground with an initial velocity of 20 meters per second at an angle of 30 degrees to the horizontal. So we know the initial velocity v equals 20 meters per second, and we know the angle is 30 degrees. Question A. What is the initial horizontal and vertical velocities of the ball? So what is v naught x, the initial horizontal velocity, v naught x, and what is v naught y? V naught y is the initial vertical velocity of the ball. So we can use here SOHCAHTOA to find v naught x and v naught y. We just have to use trig ratios. Here we have a right angle triangle. We know the hypotenuse, we know the angle, so we can just use sine and cos ratios to find v naught x and v naught y. And because v naught y is opposite to the angle, so v naught y equals hypotenuse sine theta. Okay, or we can just say, I will do question A here, sine 30 equals opposite over hypotenuse, v naught y over 20, and therefore v naught y equals 20 times sine 30, which equals to, so 20 sine 30 is equal to 10. So 10, don't forget the units, meters per second. And as we can see from the figure, v naught y is upwards. So up. Okay. And what is v naught x? For v naught x, because this unknown is next to the angle, so we have to use cos ratio, because you have the hypotenuse, you have the value of theta, and you want to find the adjacent side. So we have to use cos ratio. So cos 30 degrees equals adjacent, which is v naught x, over the hypotenuse, which is 20. And we just need to make v naught x a subject, which is 20 times cos 30, and v naught x is equal to, So 20 cos 30 is equal to 17.32. So I will just round it to one decimal place. 17.3 meters per second to the right. All right. So the next question, what is the time of light? What is the value of t? So here we need to know which formula do we use to find t. So if we look at the horizontal motion formula, which is Vx equals x over t, can we find the time from that equation? We don't know the value of the range, we don't know the value of x, and we don't know the value of the time. That's what we want to find. So two unknowns, one equation, we can't make the unknown the subject. We can't solve, we can't find the unknown. So therefore, we have to use the three equations from the constant acceleration vertical motion formulas. So which equation would you use? So because I know the value of the initial vertical velocity, I know v naught y. I also know the value of ay, and I also know the value of vy at max. So I will use the first equation to find the time it took to reach the maximum height. So I need to know how long did it take to reach the maximum height, and then multiply that value by 2 to find the total time. So let's do it here. So I will use the first equation as we said. Vy is equal to v naught y plus ayt. And here we can make t the subject. So t equals vy minus v naught y over ay. So Vy is 0 minus V naught y is 10 over 9 minus 9.8. Because if you look at the vertical motion for the first half of the journey, the object is going up and across. So up, because it's going up, so we take upward quantities to be positive and downward quantities to be negative. So V naught y is upwards, so it will be plus 10, and AY is downwards, so it will be minus 9.8. So minus over minus cancels out, and 10 over 9.8 is equal to 1.02. So this is the time it took to reach the maximum height. Okay, and therefore the total time would be 1.02 times 2. So therefore total time equals 1.02 times 2, which is 2.04 seconds. So this is the total time of light, the time of light. All right, question C, calculate the range. So to find the range, I will just use this formula to find the value of xx, the range. Okay, so what is the range? I will just call the range in this case, I will just call it xx, which is the horizontal distance, the maximum horizontal distance. So what is the maximum horizontal distance? So xx equals v naught x times t. I don't know Vx, but I know V naught x. So V naught x times the time. In this case, V naught x is equal to 17.3, and the time is 2.04 seconds. It took 2.04 seconds for the ball to reach the ground. Okay, so multiply these two numbers, we get 35.292 meters. Okay, because I don't have space, I will just write down the final answer. So 35 meters. I will just round it to a whole number. All right. Question D, calculate the maximum height reached. What is the maximum height reached? So we said this is your range, and maximum height would be from here, I'll just call this xy, to here. So what is the maximum height? So can we use y equals v naught yt plus half a yt squared? I think we can, because I know the value of v naught y, I know the value of t, the time it took to reach the maximum height, and I also know the value of ay. Then yes, I can use the third formula to find the value of y or xy. Okay, so I will do question D here. So y equals, or xy equals, v naught yt plus half times ay times t squared. So v naught y is not 0 anymore. V naught y is equal to 10 meters per second upwards. So 10 times t. So the time it took to reach the maximum height is equal to 1.02 seconds plus half times 9.8. Don't forget, sorry, a times ay is minus 9.8 times t squared. So times 1.02 squared. So calculate this. Let's use the calculator. 10 times 1.02 plus half times minus 9.8. Because if we look at the first half of the journey, the object is going up and across. So the vertical motion is up, and therefore we take upward motions to be positive, upward quantities to be positive, and downward quantities to be negative. So v naught y is upwards, so plus 10, and ay is downwards, so minus 9.8. Alright, so using the calculator, we get 5.102 meters. So 5.1 meters. Alright, so this is the answer for question D. And now let's answer question E. What is the resultant final velocity? So before the object hits the ground, what is the velocity of the object? Just before it hits the ground. So we need to find Vx, Vy, and then we can find the final resulting velocity. So we know Vx is to the right in this case, Vy is downwards, so this is Vx, this is Vy, and now we can use Pythagoras theorem to find the resultant velocity, which is V. So we need to know what is Vx, and Vx, before it hits the ground, Vx is equal to V naught x. The horizontal velocity at any point is equal. Okay, so V naught x is equal to 17.3 meters per second to the right. So we know Vx, which is 17.3 meters per second to the right. And now we can find Vy. What is Vy? Just before the object hits the ground. So here we have to use one of the three equations from the vertical motion. Let's look at the first equation. Vy equals V naught y plus ay times t. Alright, so let's sub in the values. So V naught y, we know V naught y. V naught y is 10 meters per second up. We know ay is 9.8. And we also know the value of t. So we can use the first equation to find Vy. So V naught y plus ayt and now let's sub in the values. So V naught y is equal to 10 meters per second up. So because it's upwards, so plus 10. plus AY is downwards, so minus 9.8 times the time. So it took 1.0 seconds to reach the maximum height. So it took 2.04 seconds to reach the ground level, to come back to the horizontal. So here, because I want to find Vy just before it hits the ground, so we have to use the total time, which is 2.04. And calculate this, we get 10 plus 10 minus 9.8 times 2.04. We get minus 9.99 meters per second. So let's write down the answer. So minus 9.99. I will just round it maybe to 2 decimal places. So minus 9.99 equals 9.99 meters per second, and the direction is downwards. Alright, so now let's draw our vector diagram and find the final velocity. Alright, so Vx is to the right, Vy is downwards, and we are interested to find the value of V, the resultant final velocity. And to find V, we need to find the direction as well, the value of the angle. So let's use Pythagoras theorem. So V equals the square root of Vx squared plus Vy squared, so 17.3 squared plus Vy squared, which is 9.99 squared. So calculate this, we get the square root of 17.3 squared plus 9.99 squared, and we get 19.98. So I will just round it to a whole number, which equals to 20 meters per second. And then let's find the value of theta. So I will use tan ratio to find theta. So theta equals tan inverse opposite over adjacent. Opposite is Vy, which is 9.99, and adjacent is Vx, which is 17.3. So calculate this. So using the calculator, tan inverse 9.99 over 17.3, we get 30 degrees, and this angle is between east and south, so we can say east. The angle starts from east, so we write east first, and then 30 degrees, and then south. Thank you.